Hello everyone, welcome to the session of Alpha Bridge Technologies Private Limited. This is Mukesh. In this session, we shall discuss about selective Q-in-Q. For performing this test, I have taken AS200/12 XTS. In this presentation, I will explain the concept of selective Q-in-Q. First, we will understand what selective Q-in-Q is. Then, we will discuss why it is used and where it is commonly deployed. Finally, we will compare normal Q-in-Q and selective Q-in-Q to understand their differences. What is selective Q-in-Q? Selective Q-in-Q is a VLAN stacking technique used in the service provider networks. In this method, specific customer VLANs are mapped to specific service VLANs based on the configuration rules in the switch. When a frame enters the switch, it checks the incoming customer VLAN ID and adds the corresponding outer service VLAN tag. Why selective Q-in-Q is used? Selective Q-in-Q is used to provide granular VLAN mapping between the customer VLANs and the service VLANs. It helps prevent the VLAN ID conflicts when multiple customers use the same VLAN IDs. It also improves the traffic isolation by separating the customer traffic into different service VLANs. This allows the service providers to support multiple customers efficiently on the same network infrastructure. And where the selective Q-in-Q is used. Selective Q-in-Q is commonly used in service provider networks where the multiple customers need to be supported on the same infrastructure. It is also widely used in the Metro Ethernet networks and ISP aggregation networks. In enterprise environments, it can be used to extend the VLANs across wide area networks. Now, let's look at the difference between normal Q-in-Q and selective Q-in-Q. In normal Q-in-Q, all the customer VLANs are mapped into a single service VLAN. This means multiple customer VLANs share the same outer VLAN tag. In selective Q-in-Q, the specific customer VLANs are mapped to the specific service VLANs based on the configured rules. Normal Q-in-Q is simpler and suitable for small deployments, while the selective Q-in-Q provides the more flexible traffic control and is commonly used in the large service provider networks. For example, we can see how VLAN mapping works in normal Q-in-Q and selective Q-in-Q. In normal Q-in-Q, the customer VLAN 10 and customer VLAN 20 are both mapped to the same service VLAN, which is VLAN 100. This means that when the traffic enters the provider network, the switch adds the same outer VLAN tag for all the customer VLANs. So inside the provider network, both the VLAN 10 and VLAN 20 will be carried using the service VLAN 100. In the selective Q-in-Q, the mapping is different. The customer VLAN 10 is mapped to the service VLAN 100, while the customer VLAN 20 is mapped to the service VLAN 200. This means the switch checks the incoming customer VLAN and adds a different service VLAN based on the configured rule. This provides the better traffic separation and more flexible VLAN management in the service provider networks. This is my test setup. In this topology, we have 5 switches. Switch 1 and switch 5 are located at the customer side, while the switch 2, switch 3 and switch 4 are the part of service provider network. Connect the setup as shown in the figure. In this scenario, the switch 1 is located in the Delhi office and switch 5 is located in the Mumbai office. Since these two locations are geographically separated, they cannot be directly connected to each other. To establish a communication between them, the traffic must pass through the service provider network. This is the network. Switch 1 and switch 5 are at the customer end, and switch 2, switch 3 and switch 4 are at the service provider network with the VLAN 2751 and with VLAN 2752. At first, switch 1 sends a VLAN tag of 200 and 450 to the switch 2. In switch 2, for VLAN 200, it adds the tag of 2751 and for VLAN 450, it adds the tag of 2752. This is known as encapsulation process. Now the switch 3 forwards the same to the switch 4. Here in switch 4, for VLAN 450 it removes the tag of 2752 and for VLAN 200 it removes the tag of 2751. This is known as decapsulation process and sends the 200 and 450 VLAN to the switch 5. These are the two processes, encapsulation and decapsulation, will be processing in the service provider network. Let's perform this test case. For that, open PuTTY, open the switch 1. First, we are using switch 1 to configure. Here, I am attaching the script of configuration side by side so that it will be easy to configure. This is the configuration for switch 1. The configuration is completed for the switch 1. Now save the configuration with the command write all and open the switch 2. This is the configuration for switch 2. Switch 2 configuration is also completed. Now save the configuration in switch 2 and open the switch 3. This is the configuration for switch 3. Switch 3 configuration is also completed. Now save the configuration and open the switch 4. Now perform the configuration in switch 4. Configuration for switch 4 is also completed. Save the configuration and open the switch 5. This is the configuration for switch 5. Save the configuration for switch 5. Now let's check the results. Open the switch 1. Enter the command show running configuration for verifying the configuration is done successfully or not. Yes, it's done. Now for checking result, enter the command show MAC address table. It will show the MAC addresses of the PCs which are connected at the customer end. These are the 3 MAC addresses. Now open the switch 2. Enter the command show running configuration and verify the configuration. Now enter the command show MAC address table. Here 2 MAC addresses in the VLAN 2751 and one from VLAN 2752. Now open the switch 3. Enter the command show running configuration. Here the configuration is OK. Now enter the command show MAC address table. Here also the same. The 2 MAC addresses from with VLAN 2751 and one MAC address with VLAN 2752. Now open the switch 4. Enter the command show running configuration and verify the configuration. Now enter the command show MAC address table. Here also the same. The 2 MAC addresses with VLAN 2751 and one MAC address with VLAN 2752. Now open the switch 5 and enter the command show running configuration and verify the configuration for switch 5. Now enter the command show MAC address table. Here the MAC addresses are shown with their corresponding VLANs. Let's check the end-to-end connectivity.
Ping PC1 from PC3.
This is the IP address assigned in my laptop. This is the current IP address in my laptop. Now ping the switch 5 IP address. Now check the ping to the switch 1. Now check the ping to the PC1. Here the end-to-end connectivity is successful.
From
We
PC3.
are able to ping to PC1. Now let's check the ping from PC1 to PC.
3.
Let's check the ping from PC1 to PC.
3.
Ping to laptop IP is successful.
Now ping to the PC3.
From PC1. The ping is success. The end-to-end connectivity is success. This is all about the selective Q-in-Q. If any queries, please comment below.